the solution of this equation. Now there has been a tiny mistake that we have done already, and but we didn't notice it. But eventually, as we are progressing, we will come to understand, and we will like, oh yes, we made that mistake. So let's proceed. Let's take a look at example number 2, the second one. And this example, we will first, before even trying to solve the equation, we will try to use our understanding, our concept to find any solution that we can find just by using our minds. Let's say we are asked to find all the solutions of this equation. Y prime is equal to twice x times 1 minus y whole square. And now this is our equation. So on the next line we can do dy over 1 minus y whole square is equal to twice x dx. And this we have to now integrate. And what is the result of the integration on this side? Negative 1 minus y times minus 1 equal to x squared plus a constant c1. Now, so if we now rearrange all of this, the end equation comes out to be y is equal to 1 minus 1 over x squared plus c1. Now we shall consider all of this later. We shall consider these equations, these solutions later. First, let's just take a look at this equation before considering this. We can see that there is a subtraction going on here. So if we can somehow set y equal 1, this whole side becomes 0, because 1 minus 1 equals 0, 0 squared is 0, so twice x times 0 is this whole thing will be 0. And if y is equal to 1, then y is a constant, and the differentiation of a constant is 0. So it means that if y for any x is a constant 1, then this equation will be satisfied. But so as this is satisfying this equation, this is a valid solution. We cannot deny it. But from the general solution that we have obtained by using separation of variables technique, we have not been able to get this solution out of this general solution. But we argued beforehand that the general solution contains all the solutions that can satisfy this equation, and just by changing the parameter we can get any solution of this equation. But now, as we know that this is the solution, then from our previous argument it should follow that we should be able to get this solution from the general solution just by changing the parameter c1. Now how will we get y equal 1 out of this? The only way we are getting this is if we make this part 0, because there is already 1 here. If we make this part 0, then we will get y equal 1. And how will this become 0? This is a ratio, 1 over something. So we have to make this 0, this as infinity. Now if this has to be infinity, we cannot change x square. We can only change parameter. So we have to set c1 equal to infinity. Now as I have told you that infinity is a number that we cannot ever get to. It's a conceptual number. We know that there is something called infinity. It is the biggest number possible. It is the biggest we can think of. But actually we cannot even think of it. We can never grasp infinity. We can ever get close to infinity. We can use our computers to calculate the biggest number possible to conceptualize for human being, but it is not even close to infinity. The infinity is so large that practically, for all practical purposes, this cannot be set to infinity. We cannot set C1 to infinity for all practical purposes. So basically what we are trying to say is that from this equation, there is no way for us to get y equal 1 out of this equation. So what we have done is that we have already lost this solution. This solution, that is a valid solution, we have already lost this solution. So what this solution is called? It is called a lost solution. Because we have lost it through our process. We have arrived at a point where we can never get back to it. Now, just knowing that this is a lost solution and being happy is not what we are here for. We want to know how we lost it, or where did we lose it? What mistake did we make? We must have made some mistake, because the argument of general solution is solid. General solution is such a solution that if we set some variable, some value to the parameter, we can get any solution. The argument is solid there. Then what is the mistake that we made in our process that made us lose this solution? If we look closely, we will see that we brought this part over to this side, and there is an implicit assumption that we are not stating, but we are assuming. There is an implicit assumption here that we assume 1 minus y whole squared is not 0. This is an assumption that we are making, because now we are dividing something by 1 over y squared, 1 minus y whole squared. Now, if this is 0, we cannot carry out this division, but we are assuming that this is not 0, and that's why we can bring it to this side and divide dy by it. When we are assuming that this is not equal to 0, we are implicitly assuming that y is not equal to 1. This is the implicit assumption that we are making in our minds. Even without knowing, we are making this assumption in our minds. So just by making this assumption, we are losing this value. If we didn't make the assumption and acted accordingly, we wouldn't lose this value. So this is a limitation of the separation of variables technique. We end up losing some solutions of this differential equation.